All right, hello guys. So this week we're going to go over CloudFront and Global Accelerator, as well as some storage extras and some integration and messaging options in AWS. So really, this is the three big AWS architecture ideas where we're making applications faster globally, connecting or moving storage into AWS, and allowing the system to communicate without depending too tightly on each other. So this is, more as performance and building a performance and resilience unit. These services help apps serve users faster, move data more efficiently, and avoid breaking when the traffic spikes. So, global content network optimization, architecting for global scale and decoupled resiliency. So we're going to compare these two services that sound similar, I'm sorry, but solve different problems. CloudFront and Global Accelerator. So we'll start with a deep dive on CloudFront, which you might be a little familiar with from CCP. So the concept is a CDN, a content delivery network at different edge locations. So again, just like in anything in the cloud, you want to kind of compare this to similar situations that we have here in the real life, where we have servers and edge locations, edge servers. This is basically exactly how you want to compare this. Some of the key points are its caching, TTL, and origin access control, and that it does integrate with AWS WAF and Shield for security. So basically, CloudFront is AWS's content delivery network. It'll store copies of the content closer to users at edge locations again, and this is helpful for static files like images, videos, CSS, JavaScript, any type of download really. Because instead of every user going all the way back to the original server to get these, CloudFront could serve cache content from a nearby edge location. We kind of want to think about this like Amazon's warehouses. They have several huge warehouses, but they have many mini warehouses around the world. So instead of shipping every order from, one central location, they usually can just have the most commonly requested items just, closer to the customer. And that really kind of breaks that down, really what edge computing is as a whole, really using that mini warehouse idea. I think it kind of shows you, instead of having the big one, you have all these little ones that have, cache content that the users can pick up directly much quicker in that regard. And now we move on to Global Accelerator. So the concept here is you're leveraging the AWS private network for non-cached traffic. And the architecture is two static anycast IPs pointing to two different, multiple regions. And now the benefits here is the latency reduction. So it's up to 60% latency reduction and it's instant failover for TCP UDP traffic. So really, Global Accelerator is for improving performance and availability for traffic that cannot simply be cached. So if we can't cache, we're going to use Global Accelerator. And again, it's going to use the global network to route users to the best healthy endpoint. This is useful for applications where users need a live connection to the backend. This is more like gaming, financial applications, any APIs, a live chat, any of those things. Where CloudFront is like storing a copy of a file closer to the user, those mini warehouses. Global Accelerator is like giving users a faster highway to the live application. Just exam wise, if the scenario mentions, static IP addresses or global failover or non-cacheable traffic, that's when Global Accelerator is going to come in. Again, this is for your non-cacheable. Is going to be AWS Global Accelerator. Now, CloudFront versus Global Accelerator. So in edge processing, CloudFront terminates the connection, looks for a local copy of your file, cache it. Global Accelerator terminates the connection, immediately zips the data across the AWS private fiber to your load balancer or EC2 instance. Client compatibility wise, Global Accelerator is for the hero for non-HTTP use cases, like a custom gaming protocol, or when a corporate firewall requires you to whitelist a specific static IP. And then again, falling back to the security, CloudFront provides deep packet inspection for attacks with WAF, and Global Accelerator is better for hiding your backend resources behind a single point of entry to prevent your DDoS attacks. CloudFront says, can I serve this from cache? Accelerator says, how do I get this user to the best AWS endpoint as quickly as reliably as possible? Again, CloudFront's going to be for images, videos, downloads, websites, web apps, cached API responses. Um, Global Accelerator is going to be for gaming, any type of live applications or VoIP, um, corporation type apps needing static IPs, failover across different regions. And again, anything that's really, cannot be cached is going to fall under the Global Accelerator. And obviously you have a nice little breakdown here of your two CloudFront and Global Accelerators next to each other. So you can see here you have Amazon CloudFront, the layer, it's the HTTP, your seventh layer with a WebSocket and HTTP, HTTPS. Global Accelerator is more TCP, UDP. Amazon is going to have cache content at the edge, while Global Accelerator proxies traffic to the nearest region. The primary goal in CloudFront, again, is to minimize latency for content delivery. Global Accelerator is going to minimize latency, but for the network path. IP addresses, you're going to have dynamic IPs, DNS-based in CloudFront, but for Global Accelerator, just two fixed static anycast IPs. And again, just to get you on those use cases, again, CloudFront has images, videos, APIs, dynamic web. Global Accelerator is gaming, VoIP, IoT, enterprise apps, any of that. All right. So we go on to the next. So AWS storage extras, you have hybrid and migration. This section is about organizations that need to connect existing storage to AWS or move large amounts of data into AWS. Not every company moves to the cloud all at once. Many organizations are hybrid for years until they get everything on there. Some may never even get everything on the cloud. And these services will support all that. We'll start with Storage Gateway. The purpose is bridging on-prem to S3. So the types of files are S3 File Gateway, which is SMB and fast access to S3. Storage Gateway is going to connect on-prem environments to AWS storage. It lets companies keep familiar local access while storing or backing up data in AWS. So again, FSX File Gateway, low latency access to FSX Windows, FSX for Windows, I apologize. Volume Gateway is block storage, cached versus stored. And then Tape Gateway is a virtual tape library for backups. So again, File Gateway is great for moving on-prem backups to S3 while keeping a local cache. Volume Gateway provides block storage to your on-prem servers backed by S3. Tape Gateway replaces physical tape libraries with virtual ones in the cloud. So I want to think of, Tape Gateway replaces your physical backup tapes with virtual tapes in AWS. FSX for Windows is good for accessing any type of FXS from Windows file server. That just gives you a little latency there. And then the Volume Gateway block storage, think of it kind of like a cloud-backed hard drive for on-prem servers. Really, a key idea to take from hybrid storage is your organization still has local systems, but AWS is being used behind the scenes. Now, the AWS Snow family, you guys also should be pretty familiar with this from CCP. Use case is large-scale data migration, or edge computing in disconnected environments. The models you have is Snowcone, Snowball Edge, and Snowmobile. Again, Snowcone for 8 terabytes, Snowball Edge for 80 terabytes, and then again, Snowmobile for 100 terabytes. You want to choose Snowball when data transfer over the internet takes over a week. So again, Snowball family is Snowball. The Snow family is used when you want to move the data over the internet. When moving the data over the internet is too slow, too expensive, or not possible. So again, too slow, too expensive, or just completely not possible. AWS will actually ship you a physical device right to the business or customer, and then the customer copies the data to the device locally, ships it back to AWS, and AWS uploads the data into the cloud. You want to think of some, companies that have a lot of data, not always necessarily huge, but, different medical companies, even, hospitals, all doctors' offices, universities, such as Southern, media companies that have, plenty of different video and images because it takes up a lot of memory. Research organizations have hundreds of terabytes of files. Um, so uploading over that internet could take weeks. So any of these devices will be able to make it faster and more economical. So, if you see a question that says the data transfer would take more than a week over the network, think about Snowball. Because again, we want to make sure that anything over a week. That's just kind of a key. All right, the AWS transfer family and data sync. These services both move data, but they are used for different reasons. The transfer family is managed FFTP, FTPS, and FTP for S3 or your EFS, your file system. Data sync is high-speed online data transfers for on-prem to AWS or across cloud. The key difference, data sync is for active migrations. Transfer family is for user-facing file workflows. So the transfer family is useful when users, vendors, or outside systems still need to send files using traditional file transfer protocols. Think like a vendor uploads a nightly file by SFTP, but instead of running your own SFTP server, you can use the transfer family and have the files land S3 or EFS, your choice. Now, data sync is for moving or syncing large amounts of data quickly between on-prem storage, AWS services, or it also can, again, like we talked about, across cloud, which could include Azure, Oracle, Google Cloud, whatever it might be. Um, an example of that, say a company needs to migrate a file server to S3, data sync is likely the better choice just because, it's going to be easier for them to get it immediately. Um, so transfer family is for file transfer workloads, and data sync is for migration and synchronization. Application integration and messaging. So this is going to be talk about how applications communicate. In the modern cloud architecture, we often do not want every service directly dependent on every other service. The more connected everything is, the easier it is for one failure to spread across the whole system. So we want to decouple. The power of decoupling. So the problem you have is tightly coupled systems fail together. Again, they're synchronous. The solution is an asynchronous communication using queues and streams. The benefit of this is horizontal scaling and spiky load management. So, separating the parts of medication so they do not all have to work at the same time is huge because obviously, if they're not working at the same time, if one fails, they're able to, back up to the other ones. You want to think of kind of like a restaurant. I always use a restaurant in this thing because customers don't talk directly to the chef, dishwasher, or the cashier, but the order goes into a system and each person does their part, and that separation prevents chaos. Back in the day when you worked at the restaurant, they used to actually have different printers that printed out different things to your chef, to your cashier, to I don't think they ever had it for the host, but my point is that messaging was those little receipts that came out that told, hey, fry side do this, the grill side do this, bartender do this, all those types of things. So show you that the kind of decouples it so that everything comes across. In AWS, the queues, topics, and streams help systems communicate asynchronously, and that improves the scalability and resiliency. Again, if you want to think of an example would be, say you had 100,000 orders come in at once, and the application can place those orders into queue instead of trying to process everything immediately. Now we do this in Amazon AWS through Simple Queue Service, which SQS. It's fully managed by AWS. It's durable, highly available message queuing service used to decouple and scale microservices, distributed systems, and serverless applications. SQS is, a producer places a message into the queue and a consumer picks it up and processes it. So the standard queues are unlimited throughput, at least once delivery, best effort ordering. And then there's also FIFO queues, first in, first out, shook ordering. So exactly once delivery, limited to 300, or if you're batching, you can do up to 3,000 transactions a second. If the worker finishes successfully, the message is deleted. If the worker fails, the message becomes visible again, so another worker can try it. You also have a dead letter queue, which I don't have on the slide, but I do want to explain to you. Dead letter queues where messages go after they fail too many times. So this helps developers investigate problem messages without blocking the whole system. So you're able to see where a weak point is and kind of look into it. And then also, do I have? I'll go over long polling before we. Oh, I have it right here. Okay. And so the key features are. Oh, I did have the slide. I'm sorry, I thought the slide was missing. So again, we just talked about dead letter queues where messages go after failing to process, and visibility timeout, which prevents other consumers from processing a message. And now long polling. So long polling reduces empty responses to save costs. Instead of constantly asking, is there a message yet? The consumer waits briefly for a message to arrive. This reduces cost and unnecessary requests. Because again, everything we really want to focus on in AWS is keeping it up and running and trying to keep the cost low. And now the next feature we use is SNS, which is your simple notification service. The concept of this is a pub sub, publisher subscriber. The function, it's one message triggers multiple actions, whether it's email, SQS, a Lambda, mobile push. And now the fan out pattern, which we're going to actually do a lab out on. So SNS pushing to multiple SQS queues for parallel processing. So, publisher sends one message to a topic and SNS pushes that message to all subscribers. SNS isn't waiting like SQS is. It doesn't have a queue, but it's more like an announcement system. One order placed event can trigger an email notification, a Lambda function. But an SQS queue is, all the time at the same time. It all goes at the same time. So SQS is one message waiting for one customer. SNS is one message broadcast to many subscribers. All right, now that fan out pattern I just talked about, it's the gold standard for decoupling in AWS. It occurs when a message published to an SNS topic is replicated and pushed to multiple endpoints, typically SQS queues. How it works. So a producer, like an S3 event or an application, sends one message to an SNS topic. SNS replicates that message to every subscribed endpoint. Then SQS queues act as the subscribers, holding the messages for different worker groups. The reason why we use this, parallel processing. One event, like image uploaded, can simultaneously trigger a generated thumbnail worker and a log metadata worker to go to work on it, much like we mentioned the restaurant comparison. This is resilient. If one worker group fails, the message is still safely sitting in the other SQS queues. And message filtering. SNS can use filtered policies to send only specific messages to specific queues. Only high priority order goes to the VIP queue. So imagine a user uploads an image, one system creates a thumbnail, another scans the file, another logs the metadata, and another sends a notification. Each system gets its own copy of the message. So the real benefit here is its resiliency. If that thumbnail service fails, for example, the metadata service and notification service can still keep working. So when to use all these out in a graph form. So you can see here, we have the SQS. We want to model it's a pull. The consumers pull it. Consumer type, it's one consumer per message. Message deleted after use. And it decouples and buffer load are the primary goals for that. SNS, it's a push, meaning it's instant delivery. Many consumers, again, it's that pub sub, whenever you think of pub sub, you want to use SNS. It's not persistent, it's just delivered. And it has a notification fan out is your primary goal. Now, Amazon Kinesis, which actually I will be going over next. I'm sorry, this was actually out of line here, out of order. This is going to pull because the consumers replay. Many consumers, which comes through shards. The data stays for 24 hours, 365 days, depending. And what's great with this is it's real time and it's for big data and analytics. And here we go. Amazon Kinesis, the real-time streaming. So Kinesis real-time streaming data used for large volumes of data that are continuously coming in and need to be processed or analyzed. Kind of think of like website clickstream data or even an IoT sensor data too as well. I always think of Kinesis with different weather vanes and weather IoT products, and financial transactions too in real-time monitoring. So we'll start with the data streams, which is shard-based, low latency, 24-hour retention by default, and it's for collecting and processing streaming data. Now, Firehose, which is easier to manage and is often used to load streaming data into destinations like Redshift, OpenSearch, S3 buckets. Zero administration loads data into S3, Redshift, OpenSearch, and Kinesis Data Analytics. This is a SQL-based analysis on the fly, so it kind of lets you analyze the streaming data in real time. So Kinesis is different from SQS because data can be replayed by multiple consumers during the retention period. So now SQS versus SNS versus Kinesis. So really another very way to look at these. So SQS is pull, SNS is push, and Kinesis is for large data ingestion. Again, multiple consumers can replay the data. So SQS, one consumer per message, SNS, many consumers per message. And again, Kinesis is multiple consumers. So SQS, you want to use that when work needs to wait in line and can be processed by a worker. SNS when one message needs to be pushed to multiple subscribers. And then Kinesis is when you have continuous streaming data and multiple consumers may need to read or replay the data. So again, SQS is a line, SNS is a loudspeaker, and Kinesis just think of live data stream. Like I said, I like to think of like a weather vane pulling in the data. One more thing too is Amazon MQ. It's mainly for migration and compatibility. It supports managed Apache and RabbitMQ. For brand new cloud native applications, AWS often runs services like SQS SNS, but if a company already has applications written for Active or RabbitMQ, Amazon MQ can reduce the need to rewrite these. If the question mentions legacy applications, existing message brokers, or even Active MQ or RabbitMQ JMS specifically, you want to think Amazon MQ. Again, it's for migrating legacy applications, managed Apache ActiveMQ or RabbitMQ, and use when you don't want to rewrite code to use SQS SNS. So again, that's really when they already have something already set and they don't want to redo it. Some final exam tips. So you want to use CloudFront for web assets. You want to look for clue words too. Cache content or web acceleration, CloudFront. Static IPs, TCP, global failover, non-cacheable traffic. That's Global Accelerator. Queue decouple works for SQS, publish to many subscribers, SNS. Again, real-time streaming data, Kinesis. And then, as we just talked about Amazon MQ, any legacy messaging systems. Really, a common theme is choosing the service based on the communication pattern, whether it's cache, route, migrate, queue, publish. What am I forgetting? Kinesis, stream, or again, if you want to support the legacy messaging, something they already have, you want to use MQ. So again, global, use CloudFront for web assets. You want to use Global Accelerator for network performance. Storage gateway for hybrid, Snowball for offline migration. And messaging, we're going to decouple with SQS, fan out with SNS, and stream with Kinesis. All right, guys. Yeah, so that is the end of this. If you have any questions, let me know, and I will see you guys for lab on Thursday. Thank you.